Hello, I'm Tim Hinkle, the Assistant Commissioner for the Division of Modal Planning and Program Management at the Minnesota Department of Transportation. Welcome to this four-part video series on transportation asset management, developed by the Federal Highway Administration's Transportation Asset Management Expert Task Group, or the ETG. As chairman of the ETG, it's my hope that you'll find this video helpful as you implement an asset management program in your organization. Through the ETG, the Federal Highway Administration is promoting transportation asset management with its partners at the American Association of State and Transportation Officials, Association of Metropolitan Planning Organizations, and the Transportation Research Board. Transportation asset management is important for any agency that plans, owns, or operates a transportation network. Asset management is a strategic and systematic process of operating, maintaining, and improving physical assets, with a focus on both engineering and economic analysis based upon quality information to identify a structured sequence of maintenance, preservation, repair, rehabilitation, and replacement actions that will achieve and sustain a desired state of good repair of the life cycle of the assets at minimum practicable costs. In order to support the growing interest in implementing asset management and the federal laws and regulations concerning asset management, FHWA established the ETG with the mission to support the increased interest in transportation asset management in order to sustain our nation's transportation infrastructure. The ETG membership includes representatives of state DOTs, the Transportation Research Board, metropolitan planning organizations, academia, and international transportation officials. It also regularly engages representatives from transit agencies and local governments. The ETG provides one of the few forums in which representatives from these various disciplines can meet and discuss how to coordinate their efforts to support sound asset management. The main activities of the ETG are to, number one, describe a framework for the financially sustainable management of infrastructure that integrates asset management with performance management, risk management, long-term financial planning, and sound stewardship of our nation's transportation assets. Second, identify strategies to advance asset management practices. Third, support states in their change management efforts. Fourth, address gaps in our collective asset management practices. And last, provide a forum for discussing emerging asset management issues and agency needs. This four-part video series represents one of many ETG outreach activities. The 4 videos in this series and the companion white papers cover the following topics: integrating transportation asset management into agency business practices, developing human capital and organizational culture to support asset management, integration of transportation asset management into the planning process, and defining cross-asset decision-making. Look for the video series and a wide range of resources, including more information about the ETG, at the Transportation Asset Management Information Portal at tam.transportation.org. This video addresses the topic of trade-offs between asset classes and asset programs. This video and its briefing paper have modest objectives. They seek to begin a dialogue on how to define and categorize different trade-off methods. Terms such as cross-asset trade-offs, cross-asset allocation, and cross-asset optimization are commonly used. Agencies display an increasing interest in the general topic of how to make trade-offs and how to optimize their investments. However, the ETG members perceive uncertainty in how these terms are used. We think that different agencies may use the terms differently, leading to confusion about what types of trade-offs agencies should pursue. We hope this video and its white paper begin a discussion that eventually leads to a standard set of definitions. Just as we collectively have defined what we mean by asset management or management systems, we hope our industry can agree upon a standard set of definitions for trade-off processes. As I mentioned, processes for making trade-offs are frequently discussed but seldom defined. Agencies frequently discuss trade-offs because they face them all the time. Officials seldomly have all the resources they need, so they make trade-offs between categories of assets and between other programs such as safety or new capacity projects. While making trade-offs is not new, the need to formalize and document trade-offs is more acute. As agencies develop formal asset management plans or highway safety plans, they're documenting their decisions. When these decisions are put in writing, it sparks the desire for options to document and explain decision-making. This video and its white paper address three commonly used terms: cross-asset trade-offs, cross-asset allocation, and cross-asset optimization. We offer definitions of all three categories in hopes of generating discussion and feedback. Our hope is the discussion will prompt additional research and conversation that eventually leads to commonly recognized frameworks for trade-offs and optimization. As I said, the ETG's objective is modest. We propose definitions in this video for three categories of trade-off processes. We believe the first step toward developing a state-of-the practice for making trade-offs is to define the types of them. With a common definition, we at least can discuss the various trade-off methods with some confidence that all parties are sharing a common set of definitions. To advance the practice of trade-offs, we believe we must first define them. Our first definition is of cross-asset trade-offs. As you can see, we propose to define them as a decision-making process by which resources from an asset class are transferred to another to maximize perceived utility. By utility, we mean any defined benefit. The benefit could be a mile of pavement that meets its condition target, or a probable reduction in crash frequency. We do not propose a narrow definition of utility, but rather assume it to be any positive attribute the agency seeks to achieve. Also note we use the term perceived utility. We are not in this definition inferring a rigorous analysis of mathematically based utility functions. Rather, we are speaking of decisions that are more informal, in which agency officials perceive that one need is greater than another and transfer resources from one project or program to another. In this example, we have two different asset classes. Bridges are the blue assets, pavements are the green assets. If the cylinders represent needs, then the pavement assets have more needs than the bridge assets. In order to maximize utility, the transportation agency would want to transfer investment resources among asset classes in order to balance the needs. Based upon data such as poor performance among the pavement assets, they may transfer funds from the bridge assets to balance their investment resources with their asset needs. This type of trade-off is what we mean by cross-asset trade-off. It is rational and fact-based. The officials have undisputed facts upon which they based their decisions. Pavement conditions were declining, bridge conditions were above average, and a shift in resources was justified. Their decision is easily explained and not reliant on any complex management system or decision process. The downside of this type of decision-making is that it can be hard to quantify the utility or the economic benefits. The agency intuitively knows that excessive amounts of poor pavement are not good, but how much investment is warranted to optimize investments may not be certain. Often, these decisions are made by a few officials and may not be widely documented. The bridge program manager may or may not know why program funds were cut. The individuals involved in the decision can justify it, but they may not think to widely share their decision-making. Staff may not understand the intent of the decision and how it supports the agency's objectives. The decision may not be documented so that it can be shared with appropriators in the legislature or the governor's office. The trade-off is rational, but may represent a missed opportunity to document the decision for wider understanding of the agency's asset conditions and financial constraints. The next type of trade-off process we describe is more sophisticated. Instead of looking at just two asset classes and trading off resources between them, this process attempts to quantify multiple programs or asset classes simultaneously and then select the highest overall investment options. We propose to call this cross-asset allocation. The word allocation infers more of an economic or utility-based distribution of resources than occurs in the cross-asset trade-off process. We define cross-asset allocation as a decision-making process by which resources to multiple programs or asset classes are distributed based on the simultaneous quantified prioritization of utility. I'll draw to your attention the two words simultaneous and prioritization of utility. They try to capture our intent to define a broader, more comprehensive trade-off process than seen in the first example. It is possible to identify several types of cross-asset allocation processes. However, we are going to address just three. They are benefit-cost analysis, multi-criteria decision analysis, and risk-reward-based allocation decisions. Most officials are more familiar with benefit-cost analysis at project level than at a program or asset class level. At its simplest, benefit cost captures the life cycle benefits of projects and divides them by their cost to produce a ratio. Dissimilar projects can be compared, and those with the best ratios can be selected. Some payment management systems allow for benefit cost analysis of different program levels and program types. If the agency makes similar program level benefit cost analysis for bridges and other assets, cross-asset trade-off could be made. Benefit cost is difficult to apply across many programs because it's hard to quantify dissimilar benefits. Also, it can be difficult to estimate program costs when the scopes of individual projects are early in the planning process. Also, it can be difficult to estimate program costs when the scopes of individual projects are early in the planning process. Despite the difficulties, benefit costs hold promise for further research into cross-asset decision-making. The ETG is interested in examples in which benefit costs can be applied for making cross-asset trade-offs. The second category of cross-asset allocation we'll discuss is multi-criteria decision analysis. We include this category under this definition because it allows multiple projects and programs to be evaluated simultaneously, although somewhat subjectively. Multi-criteria decision analysis, or MCDA, evaluates various options by their attributes and applies points or values to how each option performs. These types of processes are common in decision-making, such as for selecting a new highway alignment. Each possible alignment could have different costs and impacts to resources such as wetlands, farmland, neighborhoods, streams, or historic resources. No one option is perfect. However, MCDA allows each option to be viewed simultaneously by its costs and attributes. Depending upon how the options are scored, numeric or qualitative values could be assigned to each option. The best option is the one with the least impacts or the most benefits. The values assigned to an attribute could be thought of as a utility in the case of benefits or disutilities in the case of negative impacts. Among the benefits of MCDA are that it is transparent. A matrix is used to evaluate each option, and how the options fare is readily apparent. An example for program allocation could be that an agency has an extra $100 million to allocate. It could develop an MCDA matrix and plot the benefits of allocating the funds between different programs. The benefits of a greater safety investment could be compared to the benefits of more pavement investments. Other benefits are that MCDA creates a common denominator for dissimilar options. Each are assigned points or values, and those can be compared. MCDA also allows decision makers to assign weights to certain values. Community values for intangible attributes such as livability could be recognized through the weights. Finally, MCDA is flexible. A scoring matrix can be devised to reflect a wide variety of criteria. MCDA has several drawbacks as well. It may or may not capture effectiveness. Assumed in the analysis is that all options are equally effective at addressing some need, which may not be the case. Also, unless options are thoroughly screened, MCDA must assume that all the options are equally viable. Also, MCDA results are heavily influenced by the weights. Changing the weight of one category can change completely the rank order of priorities. This trait can be useful for sensitivity testing, but also can discredit the process if priorities shift abruptly. Related to the weighting is that MCDA can provide the appearance of objectivity but be very subjective. It can be subjective unless those assigning weights and values do so objectively and consistently. Consistency can require common definitions, scoring scales, and rating methodology to make the process objective. The next cross-asset allocation process we'll discuss is a risk-reward-based process. The ETG readily acknowledges that risk-reward-based allocation processes are not commonly used by transportation agencies. However, they are common in the worlds of finance and insurance. Because of the interest in risk-based decision-making, we hope to spark interest in exploring further risk-based investment decision-making. An advantage of risk-based decision-making is that it could acknowledge uncertainty or risk. In discussing MCDA, we noted one of its drawbacks is that it assumes all options are equally viable at achieving their objective. However, we know this is not the case. Some options have a high degree of success and others don't. However, the options with the lower degree of success may have a much higher potential return. Risk-based decision-making allows a decision-maker to weigh potential rewards with potential risks. There may be times when a low probability but high potential investment is attractive. At other times, agencies may want only high probability investments because they cannot afford the risk of failure. Although not widely practiced today, we hope that researchers will explore the role risk can play in decision-making. Researchers may want to examine practices in the insurance and finance industry and see if they hold parallels that we could incorporate in our agencies. We also would like to hear of any pilot efforts by agencies who may be making risk-based investment decisions. Others could benefit from hearing about these pilot efforts. We also hope that these examples lead to a greater understanding of how risk can be applied to many aspects of decision-making. We know that there is interest in understanding risk, but we are lacking good examples of how it can be applied. The last type of cross-asset decision-making we'll discuss is optimization. It's a very promising area, but not one that is widely understood. Many of us use the term optimization informally to generally mean reaching the best decision that we can. However, it also has more formal meaning. In formal settings, optimized decisions rely on clearly identified values, constraints, and mathematical formulas. As you see here, we define cross-asset optimization as the use of recursive mathematical computations to determine the maximum utility for a given set of investments constrained by defined performance parameters. To break it down further, let me emphasize that optimization relies on performing a large number of computations to determine which mix of investments produces the highest return. These computations generally require the use of software that can compare hundreds, if not thousands, of different scenarios. The computations are recursive because they cycle through many variations to reach the one with the highest utility. Optimization also relies upon predefined utilities. That's another way of saying the decision makers identify in advance what values they assign to different potential outcomes. An example could be how they value smooth pavements compared to sound bridges. The decisions are not binary, either-or decisions. Rather, they are sliding scales that would compare gradients of benefit against one another. The comparison of alternatives is calculated upon the predetermined utilities or values that the decision maker assigns to each variable or potential output. The final key concept in the definition is the idea of constraints. The optimization is not based upon the sky is the limit potential outcomes. In reality, all analyses are constrained by money or minimum performance. An agency will not let pavement or bridges deteriorate below a given point, or they may not need 100% achievement of asset targets. Constraints are predetermined by the user, and the calculations are conducted within the parameters of the constraints. So in summary, this definition specifies optimization as one particular and rather complex type of trade-off analysis. Although possible, it's unlikely that agencies will conduct optimization analysis without some type of software. The number of computations generally is too great to optimize manually. The software could be as simple as some Excel add-ins, which exist for similar optimization analyses, or the analysis could be conducted by more sophisticated proprietary software packages. The more complex analysis usually include a good deal of interviews and workshops with decision makers. These interviews and workshops help identify the values and parameters that are used. The software is not a black box. Rather, it relies on agency-supplied inputs such as how much money is available, what the agency values, and what are its constraints. Some who have undergone optimization analyses say that the workshops and identification of values and constraints holds the greatest value. The effort requires the agency to consider and state its objectives, constraints, priorities, and values which may have been unspoken in the past. The act of preparing for the optimization routine requires self-reflection and identification of values that stimulate the agency's decision-making. Optimization provides many benefits. It requires clearly stated objectives and constraints which contribute transparency to the decision-making process. The agency needs to clearly state its priorities, its values, and identify its resources to conduct the optimization analysis. The computations are mathematically rigorous, which can add to their credibility. The agency has not just considered one or two alternatives, but perhaps thousands. The number of alternatives can be exhaustive and are far beyond what is possible with manual analyses. Optimization borrows from the best practices in the private sector. Investment funds use optimization to determine the best mix of potential investments, allowing them to consider thousands of options. Similarly, a transportation agency could use the optimization routines to demonstrate it has a borrowed and best practice from the corporate world. Optimization also demonstrates due diligence. The agency can demonstrate a good faith effort to seek the best investment alternatives out of nearly infinite numbers of possibilities. Optimization creates several drawbacks. The data to analyze a large number of options are extensive, and perhaps so extensive that agencies can't produce them. It also can be hard to place a credible value on some hard-to-measure factors. How much weight would an agency add to concepts such as quality of life? Also, a pure optimization routine could allocate much more money to one region or community based upon its condition. Whether such condensed investment is acceptable statewide may be an open question. The process also may be difficult to explain. A process such as MCDA may be simple, but it is self-evident how it produces priorities. Optimization computations occur within a software package. Whether the computations are understandable to lay people may be open to debate. Despite its current drawbacks, the ETG and the asset management community at large are very interested in expanding the use of optimization routines. We believe they hold tremendous promise for helping us to make investment decisions. In summary, we hope this discussion of trade-off and optimization processes stimulates your thinking and understanding. This is a relatively new field and one that deserves our attention and understanding. Making trade-offs is very important and represents some of the most difficult decisions we make. As we formalize our decision-making by developing asset management plans and highway safety plans, it becomes increasingly important to make credible decisions. It is also critical that we document our decisions in an understandable way. The different tools for making trade-offs and performing optimization analysis are intriguing. They provide the potential for us to make credible, transparent, and justifiable decisions in a complex and constrained environment. We hope that this video and its briefing paper contribute to the understanding of trade-off and optimization processes. We don't see ourselves as the arbiters of definitions or the determiners of standards. To the contrary, we hope we just spark a discussion and begin a dialogue with the entire transportation community. We hope this discussion leads eventually to a consensus of how we define and apply different processes for making trade-offs and optimizing our investment decisions. We ask the research community to consider ways in which it could advance our understanding of decision-making, trade-offs, and optimization. We also ask that if any agencies are using any of these tools or processes to let us know. The ETG is interested in your experience and insights. If you go to the TAM portal, you can send us an email with your comments or your experiences. Let us know of your opinion of the definitions we have proposed. Please let us know if they're useful, accurate, and understandable. Also, please pass along any experiences you have that could make for a case study. We would be interested in hearing from you. We seek to engage the entire asset management community in a discussion of this promising field. On behalf of the ETG, thank you for watching.